What do you think is worse? Testing your services with in-memory databases, the ones you would never use in production, or testing services using mock data, the one which could come from a file or from a mocking framework? In both the cases, who would test your assumptions? And what if the implementation details change for the data that you use in production? How would you ensure that your mock data is correct? And if you think neither of this is a good choice, let me add another option to you. What if you could test your services locally with a real database, which might ease? If the last option sounds exciting, this session is for you. Hi everyone, thanks for joining in. I'm your host, Mala Gupta. And today on IntelliJ Idea Live Webinar, I'm excited to host Marco Behler, my colleague from JetBrains. And in this hands-on session, Marco will demonstrate how to test your code with database using Testcontainers locally. Welcome, Marco. It's a pleasure to host your session today.
Hi, Mala, and it's very great to see you. So Testcontainers, hopefully we're going to manage to answer all the questions you just posed. And we're gonna talk about, we're basically gonna take everyone who's watching from being a Testcontainers zero to hopefully a hero. And the way you might know me is that I don't like theoretical talks and giving you kind of a reference talk about here's the A to Z features of Testcontainers. Instead, we're going to keep it practical and a bit fun. Essentially, what I want to do is I want to have a little role play, imagining it's my first day at work at a new company. And I have a colleague I want to bring up to speed with my project and see how Testcontainers fit into the whole project lifecycle, essentially. And so that you can take everything you see here in this session away and really apply it in your day-to-day work. And that is also why we have a special guest today.
Hello.
Hi, Trisha.
Hello, Trisha.
Hello.
Right.
I think I would have lots of fun seeing both of you asking questions and answering questions. So I can relax and just see you both talking with each other.
Yes. So Trisha is hopefully going to hammer me with questions about Testcontainers or the stuff I'm doing right or wrong. We'll see about that. But essentially, I'd just say, Trisha, should we basically jump right into Testcontainers and then, see what's going to happen?
Yes, absolutely.
And, I'm sorry to interrupt, but before I let both of you take the stage, let me share some quick housekeeping details. Everyone who's watching, please use the YouTube chat to post your questions. We all would answer the questions as you post them. And the session is being recorded and it would be hosted to IntelliJ Idea's YouTube channel. So if you haven't already subscribed to our channel, please do that now. And last but not the least, of course, if you like today's session, please do not miss to like the video. Marco and Trisha, I'll let you take the stage now.
Thanks, Mala.
Thank you, Mala. All right, cool. So let us start with the boring stuff. Trisha, the first day at work at a new company. And what we do need for that is a project. And actually, I created a tiny project on GitHub that you, the watcher, can clone, and then you can repeat everything I'm doing. You can essentially repeat on your own machine. And it's in the Marco Behler JetBrains repository. It's called Testcontainers Demo, where you'll find it. Just search for my name. You'll find it. Clone it onto your machine, and you're essentially good to go. It's a Java Spring Boot project. It doesn't really matter for Testcontainers, but that is the technologies I chose for this talk.
Yeah, I was going to ask you about that. I can see the Maven wrapper, and I was thinking, how did you create this? But it's a Spring Boot project.
It's basically just a Spring Boot project created with the Spring Boot initializer. It has a Docker Compose file inside because we're going to talk a bit about it as well. But then it's just a REST controller, and we're going to see it in action hopefully soon. Right, and then what you also need, Testcontainers, is essentially, and we're going to learn what that means, a wrap around an API around Docker, which means you need to have Docker installed on your machine, which means you need to have a couple of things installed on your machine. First of all, Windows subsystem for Linux. If you're on Windows, it's different on macOS and different on Linux, but I'm going to show you the Windows steps here, so you'll have to make sure to get WSL2 installed on your machine.
I really wish I'd had you with me about 2 weeks ago. I went through all of this 2 weeks ago and I couldn't get it to work properly. So now I'm going to watch you really carefully and see what you do.
Yeah, yes, yeah. And the issue is, and I can tell you, it's something I wanted to talk about in a bit, but to take it away, it could be that you're working inside a company, especially bigger companies, where you cannot install Windows subsystem for Linux, the Windows subsystem, because you need to have some, you need to enable the subsystem. You have to have some kernel files, updates, enable a virtual machine feature, whatever. If that's the case, you have to do it on a private machine. You won't be able to do it on your work machine.
I can tell you exactly what my problem was. I did not read the instructions. I just clicked next, 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 and then it didn't work properly.
Right, yeah, yes. And you have to go through all of these steps, essentially, to make it work. Then go to the Docker homepage. I never know where to click, but no, get Docker Desktop again on Windows. You just download the latest Docker download for Windows. And make sure you have the latest one. I had some weird issues with older versions. I always kind of keep it up to date. So just make sure you get that. Then you have WSL2. You have Docker installed, which is already most of what you need. And last but not least, you need test containers. Let me just...
Can I interject a little bit?
Yeah.
I did find, because I have a Windows machine and a MacBook, and I did find, so you said that you don't have to do the WSL2 thing for Mac. I just wanted to go one step further and say it really is next on the Mac. The Mac it just works when you're installing Docker.
Right. And just to basically, before we go to that homepage, let me just quickly show you. I have the project checked out on my machine. So as I mentioned, for people who know a Spring Boot project, it's a plain Spring Boot project. It has a main method, a test containers demo application, Java class with a main method. And now it's my first day at work, or Trisha's first day at work. And what happens is you essentially check out your project, and you might be tempted to just try and run it, which I'm going to do here. So my application boots up, and I get a nice little error message in the log file here at the end saying the MySQL connector, which is the JDBC driver, tries to connect to a database, and the connection is refused. So my application doesn't start up.
I actually find this weird about Spring Boot applications, that even if you haven't told it to do anything with the database, some of them, depending on your configuration, the app just won't start if the database isn't there.
Yes. In my case, actually, there is a properties file, which you'll, whoops, that was too fast. There's a properties file, an application properties file you find inside, and you'll find a couple of properties referencing a localhost database / some database, root, let's go Marco with the password, which kind of prompts Spring Boot to try to connect to such a database on startup. And now the thing is, well, what is the quick fix on your first day at work? And again, it depends a bit on your company. It could be the simple solution is, well, install a database locally. So you would basically grab a MySQL, in this case, the MySQL installation, install it locally on your machine. That's what I have. This
is what I've always done. So actually, I used to do this a lot at JetBrains. So I'm having to demo a bunch of stuff, and I have like a MySQL local and a Postgres local and a MongoDB local, and then you basically have to throw your laptop away and rebuild the whole thing later on because you don't know what's there.
That's exactly it, because it kind of, these databases kind of get, they don't rot, but there's kind of a maintenance burden with that approach, basically. You install your database, then you kind of leave it running around. You don't know what version it is, what data is there, what database is there, all that kind of stuff. But still, it is a valid approach, which I've seen companies do because they, for example, don't allow you to install Docker and whatnot, which would be the second solution. Second solution, as I mentioned, Docker would be you have your machine, you have Docker installed, and Docker makes it rather simple to just, pull down your Postgres image and boot up a Docker container and then just throw it away again.
Wait. You just said a bunch of words that if I don't really understand Docker very well, I don't understand. So right. you said pull down a container and boot up an image.
Yes.
And then throw things away.
Yes.
And I don't really know what that means.
All right. Yeah. So essentially what you have is you have to imagine that, for example, there's Docker Hub, a huge repository of Docker images. A Docker image could be it's interesting to get into what a Docker image exactly is, but just imagine you have some sort of a virtual Postgres database, or you have a MySQL database. That's a Docker image. So you could have a MySQL Docker image, you could have a RabbitMQ Docker image, you could have a Kafka Docker image. Basically, for these technologies, you have a tiny Docker image, and when you start the Docker image, it turns into a container. Oh man, that is a very simple explanation, meaning your database will run, and you can connect to it on your local machine, so to say. And then when you stop the Docker container again, your database will be gone, and you can just delete it from your machine. Did that make sense? Kind of.
Yeah, it's about like disposable installations.
Yeah, disposable installations. That's a good way to put it. Disposable installations, right? And especially for MySQL, for example, MySQL has a Windows installer, and that kind of works. If you try to get an Oracle database running on Windows, it's a completely different topic. So Docker makes some things nice, because you have, for all these databases, for example, you have ready-made official images. You can just pull them down, and you have a database up and running in, let's say, 10 to 15 to 20 seconds, essentially. And I'm going to show you what that looks like in a second. Right, which means, still talking about it, Docker. And please, Trisha, don't ask me what Docker Compose is now.
I'm not going to. No, Docker Compose I'm kind of fine with, because as someone pointed out in the comments, if you open it, it has a little green button, a little green run button on the side, and I'm fine with that. I get that.
Right, yes. And so what happens is, in companies, basically, to solve that issue with starting your application, you might have a Docker Compose file in your project directory, where you can essentially say, my Docker Compose file, what I want to do is I want to have a so-called service. It's called DB in this case. And what is that service? Essentially is pull me down the latest MySQL image from Docker Hub in this case, set a couple of environment variables so that the database that boots up is called some database, which conveniently matches the database name in my properties file with the password, which is set in my properties file. And then please bind the port 3306 from the container to my host, which is a Docker-specific way of saying, let me just be able to connect to my database through port 3306.
I'm not going to poke you too much on that, because I know Dahlia's about to do a video on that. So
right, okay.
That could be covered later.
So let's actually do that. Let's click that button, that run button up here. And I can see that basically my database is now booting up. It's going to take a second. So there's some log messages here in IntelliJ IDEA. And what I'm just going to do is I'm going to go to localhost 80. Did I boot up my Spring Boot my Spring Boot application? I did not, I think. No,
it's because it didn't run the first time you ran it.
Right. Thank you. So I'm just going to start that again.
And then it should connect to your database this time.
It should now connect to my database this time. Let me just look at my browser again. Localhost 8080. Right. And I can see localhost 8080, I basically get a JSON object back, which says there's first name Tricia G and
G.
Marco G. Sorry about that.
It's all right. It's
G.
fine.
And Marco Behler. Right. Okay. So that works. Now we solved the problem of local development for now. The question is, what happens now when I start running tests? Essentially, now I have my Docker Compose database up, which is all nice and good. So instead of having it installed on my machine, I now have a Docker Compose database up. But again, let me actually just stop my Docker Compose container. My database is now gone again. So that is how quickly you basically boot up a database and get rid of it again. And I have some integration tests. And when I run these integration tests now, I mean, again, they won't work because they're going to try to connect it to the same database, right? So you just get a huge stack trace. Essentially, somewhere at the bottom, it's going to say the same thing, connection refused.
So my naive assumption at this point, and I have literally done this, is I'm like, well, look, I have a Docker Compose file, so I'm just going to use that to start up the database and then run my tests against the Docker images which are running. Now, it's not very reproducible in other environments, but it does work.
It does. Yeah, so it kind of does work. It does work for you locally and has all the problems essentially that you might expect with an install database. So for the maintenance problems we mentioned earlier, the question is what kind of data is in your database? Does the test data pollute your local database? Do you have many different teams maybe working on schema changes? And is your database always up to date with these schema changes? And wouldn't it be kind of nice to have, as you just mentioned, some sort of a reproducible way that your tests have an empty, clean, always up-to-date database only for your tests. You don't have to worry about a Docker Compose file, but somehow magically a database boots up for your tests. And then after your tests have finished, the tests are gone again. That is the dream, basically. To spoil it, with test containers, that dream is essentially possible. So let me get back to what we need to do with some more boring stuff, because at the beginning, we just need a couple of dependencies added to our project. It's a Maven project in this case, POM XML file, Spring Boot, and we somehow need to get the test containers stuff inside to get started with test containers. And I'll just quickly go back to the homepage, test containers, and if it's the first time you're working with test containers, before I go straight to the dependencies, you might be tempted to click on the Quick Start button. When you click Quick Start, you'll see there's a JUnit 4 Quick Start, a JUnit 5 Quick Start, and a Spock Quick Start. And that's because test containers is somewhat integrated tightly with different test frameworks. So you'll have different dependencies and different even like annotations and whatnot, depending on if you use JUnit 4, JUnit 5, or Spock. And we're going to go with JUnit 5 in my case, because it's been out for 4 years or 5 years now, and
we should be using JUnit 5 now.
we should be using JUnit 5.
And you can use them together. You can use 5 and 4 at the same time.
Yes. And you can also use test containers manually, the manual API, which I'm also going to show in a bit. But essentially, choose your testing framework, your flavor. Scroll down to the dependencies. And then in a Spring Boot context, Spring Boot will basically give me all these JUnit dependencies for free already. So I don't have to add JUnit Jupyter. I don't have to add these dependencies to my project. But what I would want to do is essentially add the 2 test containers dependencies to my project. So I'm just going to copy them, test containers, and the JUnit 5 bridge, so to speak. I'm just going to add that to my project. And I have to learn how to open up my IDE without, losing context. So I'm just going to paste that in here, refresh my project.
Command-Shift-I.
Command-Shift-I. Yes. All right. Then what we have up next, let me just see. You'll find a module section here on the test containers homepage. And on the left, you'll see you have different database modules. So you have my favorite name, CockroachDB, DB2, ClickHouse, MariaDB, MySQL, Oracle, whatever. You have a ton of different modules, test container modules. You even have modules for Kafka, for Nginx, for whatever, RabbitMQ, for WebDriver, for Selenium tests. So depending on what you want to do, you need to pick the appropriate module. In our case, for now, we want to simply start a MySQL database. So I'll go to the MySQL module and again, just fetch the dependency and copy that into my project. And also what I'm going to do is I'm going to show you maybe in a bit of time. Let me also add the RabbitMQ module just to boot up a RabbitMQ message broker in a bit. Right. So that was the boring stuff, and I still hope you're with me. I'm just going to check if in my external library section, org test containers, it looks like there's the MySQL module, there's the RabbitMQ module, and now it's time to kind of learn what these modules are actually for. Right. Let's open up the integration test. And well, our goal is we want a MySQL database. For now, we want a MySQL database whenever someone runs the custom integration test. Which means you want to write private MySQL container equals new MySQL container. That is test containers API for give me a new MySQL container. There's a couple of things about this now. First, you can see that the constructor I'm calling is deprecated. That's because what they wanted to do is put in a Docker image name. Docker image name, and that refers back to what Tricia said at the beginning, is when you go onto Docker Hub, for example, and you search for MySQL in my case, you'll find the official MySQL image. And when you scroll down, you will see there's specific versions of that image. So there's the 8.026 version, 8.0 version, 8, latest, 5.7, 5.6. There's a ton of different versions or tags in Docker speak. And what you need to do is you need to decide, well, I want the MySQL image for version, let's say 8, for example, or a specific 8 version if you want to. But it doesn't really matter, whatever suits you. So you're just going to go back and put in MySQL version 8 here, for example, or 8.026, or latest, whatever you want.
My assumption is that you probably want to tie this to whatever you're running in production.
Yes, you want to tie this to whatever you're running in production, in your staging environment, in your whatever production environment. Make sure that you have the same database version. So in my case, now 8.026, across all your environments, essentially. Right. Then this line here, it doesn't really start a Docker container it doesn't start your database, your MySQL database, whenever you run your test. You need to basically invoke the Testcontainer JUnit integration, which you do by using the add Testcontainers annotation on your class. And then Testcontainers will only start and stop containers, which are also annotated with the add container annotation. Right. So now what's going to happen is Testcontainers will have a look when your test starts. Which containers do I have inside my test annotated? And if it finds such containers, it will start them and it will stop them. And it will do that every single test method, which is not what we want. Because what's going to happen now is, let me just explain that again. If you have it like this, what's going to happen is, this test method gets executed, and before the test method, I get a new database. After the test method, database is gone. The next test method is executed, I get a new database. After the test method, the database is gone. So now we went from having just one, monolithic, unmaintainable database installed on your machine to having a new database for every test method, which is essentially the other extreme, kind of.
There's definitely a balance there, isn't there? Because especially with database testing, it's always a bit of a question of like, am I supposed to be trying to trash it at the start and end of every test, so I know my starting state and my end state? And also, if you're running a lot of tests in parallel, then you don't always want to be using the same database. But on the other hand, like you said, the cost of starting up and tearing down is non-zero.
Yes. It's an interesting balance to have, especially with parallel tests is yet another, let's say, interesting topic, especially on CI pipelines, how you split up these tests. But for now, we'll see that in a second. What we're trying to do is at least get one database per test class and then one database per test run. So for example, that you have always a fresh database for all of your integration tests for now, assuming they're not parallelized. Hopefully that was a word. And we're gonna work towards that goal basically, and find the right balance. And to get that first step going, so just to have one database for this one test class, there's a simple fix. You just make the container static. So you will just have one MySQL container for the custom integration test class. It will be started before you run all the tests in this class, and it will be shut down afterwards.
But then you do need to be careful of if those tests are going to trample all over each other's data, right?
Yes, you have to be careful in that case. Yeah, as always. Yeah, then as not as always, but as normal, basically. Then you have to be careful that the tests don't, trample over each other. Right. And just to kind of finish off with that, the thing is, if you're new to test containers, you might now be tempted to do something which is not recommended. And if you just, jumped in right now in the session, you might be thinking Marco doesn't know what he's talking about. But let me show you the wrong way to do it. And then we're going to learn about the better way to do it. So let's say not the wrong way, but you might be tempted to have a look at your properties file and say, well, I need a database which runs on localhost 3306, and it's called some database. And the username needs to be root, and the password needs to be let's go Marco. So you might be tempted to go inside here and say, well, let's start a new MySQL database /container with the database name some database, with the username root. Let me just put that in, right? And with the password Marco. Something like that. Let me actually just quickly boot up the application. And that is my first side note, by the way. I have quite a beefy machine here, which I'm demonstrating this on. And you'll see that actually it takes some time to start a container, a MySQL database from scratch. So you'll see there's some endless log messages here, which is actually test containers waiting for the MySQL container to start up. So the MySQL database is ready. And it took me about, 10 seconds or whatever that was, something like that. So let me just scroll down and see what happened here, because the test is still red. I still get a connection refused. Now, why is that?
I like the way it said connection refused, no further information available.
Yeah,
great, thanks for that.
Connection refused. So when you have a look at the log, what you'll see here, let me just see if I can scroll to the right a bit. As I just mentioned, test containers will start your Docker container, your database, and then it polls the database every 100 milliseconds or so to find out if the database has started up. And you can see that it tries to connect to localhost, and then the port number is 49155. Some database is correct, but the port number is wrong. And the password Marco, right, that looked fine, and the user is root. So that is all fine, but the port number is off. And when I have a look here and say that there is no with port, essentially, there is a with expose port, which is something else, but I cannot set the port number. And that is one of the concepts in test containers. The port numbers are generated randomly. Why? Because if you want to start up a container for your tests, what does it matter what port your database runs on? What happens if the port is already used by another project? And that's why test container will boot up your database and give it a random new port, basically on every test run. Which is a bummer for us.
So that does leads to the next question. Okay, how do I know what port I'm supposed to connect on?
Yes. So the thing is, what you can do is you can ask your test container, you can ask your MySQL container, hey, what is the port basically I need to connect on? Which also means the roles are kind of reversed, because now you need to boot up your MySQL container, and then you need to tell Spring Boot, hey, the URL in your properties file you try to connect to, that's the wrong URL. Please use a different URL, at least with a different port number. Which brings us to the topic, how do you tell? And that is, unfortunately, is a specific, it's specific to the framework you're using. So in Spring Boot, for example, there's a property, it's called, there's an annotation called dynamic property source, where you can override the properties in your application properties file for your test runs. So override props. And then you need a dynamic property registry, hopefully. Let's see if I have that right. And something like this. And then you say Spring data source URL. Well, the URL should not be the one in my properties file, but rather it should come from my MySQL container.
Oh, that's cute. I like that.
And because that registry add call wants a supplier function, you actually don't call container.getJDBC URL here at that point already, but rather you give it a method reference so it can be called anytime later on. And that way you basically tell Spring Boot, hey, use the URL that you get from test containers.
So you let test containers basically control all of that and then tell Spring where it is.
Yes, exactly. So what we're going to do is again, I just started the test. Again, we have to wait for, I don't know, 10 or 15 seconds to see if hopefully now my test is green and everything, I don't know, Spring Boot was able to, yeah, let's see. Looks better. It was red. Let's see what happened now. I didn't expect that, to be honest. Access denied.
Your password's wrong.
My password's wrong. Let's see. What was the password? Let's go, Marco. Oh, sorry. Right. So
people in the comments were sort of saying the password's wrong. The password's wrong.
you can already see that is actually the issue. Now, what I'm trying to do is I'm trying to boot up my test containers thingy and set the right username and the right password and the right database name to match whatever. And again, the thing is, for tests, all of this shouldn't, basically be an issue. What does it matter? What's the database name? What's the username? What's the password? And we're going to have a look at that in a second. But now let's hope this works. Trying to create, and you can see 10 seconds. Again, right.
Yay!
Success. Everything worked as expected. Okay, cool. Now that worked. And as I just mentioned, the thing is, let's forget about the password. Let's forget about the username. Let's forget about the database name. And let test containers actually use a dynamically generated name. And the funny thing is, test containers won't actually, I think they won't dynamically generate a name, but they will use test as a default. So test for the database, test for the username, for the password, but it doesn't really matter, because what we're going to do is we're going to duplicate the lines down here. And we're going to say Spring, the username should be coming from test containers from the username method. And the password should be coming from test containers and the password method, right? So we're just overriding all the properties from the application properties file.
Do you know if this works for, I was using test containers for MongoDB, but I was doing the dumb way. Does it work for things like MongoDB as well? Because it's a different set of properties. It works a different way.
Yes. So the thing is, and actually it's a good point. The thing is now, what essentially, so MongoDB specifically, I haven't tried it, but yes, I suppose, because the question now is, what is test containers actually? And let me just show you what, again, while my application is booting up, actually, you can see everything is green. That worked as expected. So we're just overriding the properties, test is green, everything is perfect. Imagine we had our with username method here. We had our with password method here. Now, what does test containers actually do? Test containers at some point has to do a Docker run, MySQL 8026. And in Docker, everything is done with environment variables. So they're just going to set an environment variable, which is called MySQL username or something like that. And whatever you put in here, basically. And then you have a new environment variable, MySQL password, or whatever it's called, whatever your Docker container, the Docker image supports, basically, something like that. So this here is essentially being translated to a simple Docker run command with all the values replaced. So it's a tiny wrap around that, which means that every one of these containers has special methods, which you'll find in bold highlighted here, where you can basically set the environment variables that your Docker image supports. And for MongoDB, I'm quite sure you'll have the same properties, environment variables. For RabbitMQ, for all of these different modules, especially, you have your own container classes, and you can call these methods. I think I lost Trisha here.
No, I was just looking, because I was looking at my code for MongoDB, and you can set the replica set URL, which someone was asking about on the comments. So that's useful for MongoDB.
Yes. And what else? I can show you a bit more about these containers in a second. But first of all, nothing basically stops you from starting and stopping as many containers as you want. So as I just mentioned before that, I added the RabbitMQ dependency. So I can also add a RabbitMQ container, RabbitMQ latest, or whatever the version number is. And you'll find, if you use the with methods, you'll find all the RabbitMQ specific properties you can set. So with exchange, with bindings, so that are messaging specific properties / environment variables later on, with Q, with SSL. So essentially all these tiny modules that have these classes like RabbitMQ container, MySQL container, MongoDB container, Selenium containers, whatever, where you can configure your container, boot it up, and even get stuff like the JDBC URL, username and password from the container. Also, if there is no module, for example, I don't know, you have your company specific library, or if Testcontainers doesn't support a specific library, you always have the possibility to start a generic container. Generic container, just put in your Docker image name. So I don't know, my image, my tag, whatever, and it will boot up any Docker image you want for your tests. So these are the options you kind of have. As long as you have enough memory, enough RAM on your computer, enough RAM and CPU, and your computer doesn't die by heat, by booting up all these Docker images.
That's what I was going to say. You said you can have as many of these as you want. I'm like, I don't think you can.
Yeah. So yeah. So there's some very hard limits to it, defined by your hardware, basically. Right. Then I already talked a bit about. So the plan is actually, as we said, is not even now that the way we have it now. Actually, let me just comment this out again. We have one MySQL container per test class. And again, what I want to do is I want to have a MySQL container for a whole bunch of test class. And also I want to get rid of that startup time and find out if there's a better way, instead of having to wait for 10 or 15 seconds, if there's a better way, because otherwise I'm not tempted to license collision detected. Reactivate. Let me see. That is a bit
Someone's
sad.
using your license.
Hopefully, who is using my license? What happens when I click reactivate? Let's see. Hopefully, my IDE is not shutting down. Right. Okay. That was new to me. Where were we? Yes. What I ideally want to be able to do is I want to have no startup time, no container startup time, or as little as possible. Or otherwise, it will be a problem running my tests, always having to wait an additional 10 or 15 seconds till my container boots up, essentially. And we're gonna come to that. But first of all, I just want to show you a couple, or teach you a bit more about, let's say, useful methods you might want to invoke on your container classes. I already showed you, and I'm just going to put them in here. I already showed you all these with methods, where basically when you construct it with password, with username and whatnot, there's some other things which you might be interested in. For example, there's the container with class path resource mapping, which means you have a file on your class path, like your schema SQL file here, or your application properties file, and you want to make something like this, so application properties from your class path, and you want it to be available in the temp folder, for example, inside your Docker container. Then you can simply use that method here. It's super simple to get a file from your class path inside your Docker container.
That is extremely helpful. I didn't know you could do that.
Yes. There's also the same thing, file system bind, which means you have a file on your machine. So in my case, it might be cdev, whatever application properties, the same thing, essentially. So you just take that. You bind it again inside you have to take the same name, just to confuse people. Make it read-only so that the Docker container can only read to you from the file, or make it also writable so that the Docker container can write to your file. But these are two things you might use a lot, actually. If you want to execute something inside a running container, like some command, I don't know, like printing out the current directory. You're going to use exec in container, and you're going to make sure the command will be an array, so not have it like this, but rather have every parameter as its own array value. Did that make sense? Yeah. So you can just execute something inside a container.
Kevin says on the comments, by the way, we generally consider copy file to container the better approach since it's more portable.
Right.
So now you know.
Now I know. What else would you probably want to do with get logs? Yes. So the Docker container has like a system out, system error. What you can do is if you want to get logs, you'll just get every output. If you have a specific output type, if you just want to get the standard out, you can call that essentially, and you get the access to the standard out of your container.
So you could wait. So you could use that to write tests which examine what gets printed to stand it out.
Yes, yes.
That's also very helpful.
Yes. So I can't even add much more to that, but that is essentially exactly what you would do.
Of course, you shouldn't really be writing stuff to stand it up, but that's neither here nor there.
Yes, yeah. And also with the let me just double check with the log consumer. If you just want for whatever reason, you want to consume the log. And maybe print it to your own, like however you have SLF4J configured, you can input like an SLF4J log consumer when you start your container, and then the messages, the standard out from your container will get redirected to SLF4J. So there's all sorts of things you can essentially do. Now let me see, what else did I forget? What might be useful? Right. Remember, what we said is the container starts up MySQL database. And the funny thing is the port is random, so you don't know the port. If you want to know the port, however, what you want to do is you want to call get mapped port. And for that, you need to remember that MySQL in that case by default has 3306, which is available on the container. So on the container, you have 3306 available. But on the host, so on my machine where I run the tests, it's bound to a random port. And when you call get map port for 3306, you actually get the specific port number on your machine.
On machine, okay.
Yes.
I get my ports back to front all the time, but yes, it's useful to know about that.
Yes. So that is essentially the port number that is also inside the JDBC URL. So what you saw earlier, like 45,000, whatever, that's the port number you'll get when you call that method. And what else? Let me just scroll down here. You can see there's a ton of other methods. Basically, you can get networks, tempfs mappings, setenv. But let me just the wait strategy. There's more advanced stuff, which I guess for now, I just want you to take away like 5 things: class path mappings, file system binds, exec and container. You can get the logs and you can get the port. If you remember any of these 5 things, I'm pretty happy already. And you can learn about the rest on the Testcontainers homepage. Okay. Which brings us to one more thing. Just so you heard about it, I mentioned the with exposed ports methods at the beginning, and I said it doesn't really set the port on your host. But what that method actually does is, not only when you say the MySQL container, by default, it exposes the port 3306. But what this exposing thing does is also, it tells Testcontainers, please poll the port until it's available. So it's also a mechanism, basically, to make sure that your MySQL database has booted up completely. That must have been confusing, Trisha. Now you need to ask a question.
Yeah, I didn't really understand that. Sorry.
Okay.
I so didn't understand it that I don't even have a question for you.
Okay. Let me give you a better example, which will make it more clear. Imagine you have a generic container, something that Testcontainers doesn't know about. And it might be that you have a My Company image, whatever, and it's a REST service, something like that, my REST service. And that REST service boots up on port, I don't know, it boots up on port 9000 for whatever reason. So the thing is, when Testcontainers now starts your generic container, how does Testcontainers know when your REST service has fully booted up, that it's fully available. It will just start the container and then your test will run. And your test will run into problems because your container hasn't even started up. It takes 10 seconds to whatever be fully available and your test will already run. And you have to tell test containers, hey, there's a port which should be open. Please pull that port, whatever, every 100 milliseconds. And once you get a success message, which you can also define, kind of, then the container has fully booted up, and then my tests can run.
Okay,
and this is,
so it's a wait. It's not really. I was confused because I didn't understand that the with exposed ports is also a kind of wait for.
Yes, it's also kind of, exactly, it exposes the ports. It's also kind of, it's also, to simplify it, it's also kind of wait for. Yes.
Okay.
All right. Now let's see if Kevin has something to add on that in the YouTube comments. But essentially, that is simplified what it boils down to. Okay. Now we have that, and I already mentioned there's one thing. Well, there's one last thing I want to do. I want to demonstrate. I want to get the startup time down. And for now, what happens is the MySQL container starts up and it shuts down again after every test class. What the test containers maintainers did, they added a new possibility in terms of a setter here, which is called with reuse, which somehow signals test containers, hey, why don't you not always start up a new MySQL container, but reuse an existing one, right? And we'll have to look at that, how that works. So
I don't quite understand that, sorry.
Yes.
Like,
yes.
I thought containers were sort of reusable anyway. What's it doing if it's not reusing it? It's like a brand new... So this is almost definitely my Docker ignorance. I apologize for that.
Yes. So what you do is essentially, so you have your container, you start it up and you shut it down again for, in this case, for every, let's say, test class, which means your Docker container is stopped and it's still there. You didn't delete it, so it still contains the data. So when you restart it, it has the data, but you still have to restart it essentially.
Okay.
And now the question is, how can you avoid that restart? So couldn't we just keep the Docker container running essentially? And if there is a MySQL database running Docker container, couldn't we just reuse that kind of instead of restarting it?
Okay, I get it.
Right.
So if it's started and lying around, just reuse it.
Yes.
Okay.
So the thing is, what's happening now is there's a method that's called with reuse true. And as that feature is not 100%, I think, hopefully I'm not saying anything wrong, it's not 100% fully, let's say, production ready, I guess. You have to do a couple of things. So you have to set with reuse true. You also have to set a magic property, which you can set in environment variables or whatever. But essentially, there's a, in your home directory, hopefully you can see that on my screen, you'll have to put a .testcontainers properties file. And inside that file, there's a magic line, which you'll find out about on the Testcontainers homepage, which is called testcontainers.reuse.enable equals true, which will basically enable this feature for you. Otherwise, if you just activate the setter in your Java code, it won't do anything. So you'll need to put that line into that properties file.
Okay, I think I did not do that when I was trying to enable reuse in my last set of tests.
Yes, yeah.
Thank you for pointing that out.
Yes, that is something, yes, exactly, yeah. So, okay, so you have that. The second thing is, the second problem, and this is where I find that the Testcontainers API is not let's say, it's a super great project, super helpful project, but it has a couple of rough edges. One of these edges is that now when you set reuse, that's all nice and good. So you have with reuse here, you have the magic property set in your properties file. The problem is that the @container annotation, the test container support, it will still just shut down. It will shut down your container at the end of the test. So your container will be gone. So that doesn't actually help you.
You've completely, you've totally helped me with this because I was struggling with this last week. I kind of couldn't marry up this idea of the with reuse across tests. But surely if you're using it in a test class, it's going to shut it all down anyway.
Yes. Yeah, so that is the issue. So what essentially you have to do is you have to get rid of the test containers JUnit support and have to use test containers manually. Right. So what that looks like, delete the annotations. That is step number 1. And then you have your MySQL container here. And then you probably will have like a before all method or something like that, or even a static block, whatever you want to do. And I always forget the void today. And then what you want to do is inside here, you simply call start. Right. And then let's try it out actually. So I'm just going to click run now. And now remember, this is the first time. So what's going to happen is that still you can see this is what I talked about. This is the container is starting, and test containers pulls the MySQL container until it's available. So this takes now 10, 15 seconds or whatever, right? So that took 10, 15 seconds. Test worked fine. Let's try and run the test again, and hopefully I set everything up correctly. And now you can see that, yeah, whoops.
Ooh.
That was, let's say it was a second, right? I think it was roughly a second connected to Docker. So at 50, 26, 27, yeah, it was 1 or 2 seconds, which is much nicer, I suppose.
But you still have this thing, right? If you're reusing containers, you still have to be aware of other tests trampling all over data, maybe.
You have to, yes, you have to be aware of the test, and also you have to be aware that the container is still running now. So it's basically running on your machine. What you can do is when in IntelliJ, in the services tab, or you just do a Docker PS on your machine. Actually, I might just show it like that for people. You can see that obviously now the container is still running. So you have MySQL container booted up and still dangling around. And I think what the plan was of the test containers folks was to shut down the container after, I don't know, a specific, some time frame, while it's not being used. But I don't think they have implemented it. So the container will be lurking around, and you have to be aware of that.
So particularly if you're running it in CI, you really want to make sure there's some sort of process that like sweeps up all of those running containers.
Actually, I'd love Kevin to comment on that. Maybe he has some words on what the plans is with the cleaning up the containers. If you were using them, maybe he can shed some light on this. Yeah. All right.
I'll keep my eye on the comments.
But last but not least, we're almost there. What I wanted to do is what it essentially boils down to now is you're going to have, if you want to reuse the MySQL container with reuse for all of your tests inside your test hierarchy, you're probably going to have some sort of an abstract test. It's a great name, abstract test. You're going to move the stuff inside your abstract test. Like so, your MySQL container, and then make every test extend from that abstract test, which is not something I'm super fond of, having these abstract superclasses essentially. Oh, also I need to move the dynamic property source inside here. So everything that's specific to your test container stuff. Right, these methods don't work anymore. Something like that. There's a lot of commented out code, but essentially what I wanted to show you is you might end up now having some sort of an abstract test class which boots up your MySQL container with reuse, and then you can have as many integration tests as you want extending from that test class, and you'll have one database with whatever caveat we already talked about for your whole test run, basically.
I have an alternative suggestion.
Yes.
This is exactly what I wanted to do. I agree with you. I don't really like the extends abstract test. So in this case, you've got what would it be, like a test containers test. So this is customer integration test extends your test containers test. And there's some sorts of problems there, because what are you going to do? You're going to ram it full of all the test containers that you might possibly want to connect to in all of your tests. And because you can only extend from one test class. So it gets a little bit unwieldy. One of the things I was looking at, and I found this on I think it was on the Testcontainers home site as well, was by using the JUnit 5 extensions instead. So instead of extending an abstract test, I annotated it with extend with MongoDB container extension. So then you can have extension for each one of your containers and just annotate with the ones that you want.
Right. Very, very good point. Very good point.
I'm going to write a blog post about that as soon as I have the time.
Yeah. Right. So folks, watch out for that blog post. There's two things I'm seeing. We're actually almost, I guess, running out of time a bit, but I wanted to cover two things, two more tiny things, because we already talked about that abstract test class. We now talked about, just the whole, how do we get test containers up and running for our tests? Well, that made sense. But what about local development? Local development still means I have my Docker Compose file at the moment. And yes, there's actually a way to use test containers also for your local development instead of using a Docker Compose file. I cannot show it and demonstrate it anymore because we simply don't have enough time. But what I want you to do is search for a blog, a guy, it's super simple to remember, a guy with ego in his name. He's one of the test containers developers, a guy with ego in his name, and then just put local development here because he wrote a blog post. Sergey wrote a blog post. How can you do local development with test containers? Essentially, how can we reuse test containers when we boot up our Spring Boot application for development? And there's a couple of different choices. Essentially, you reuse some of that stuff while booting up your Spring Boot application. I'm just repeating myself here, but have a look at that blog post. It will tell you how to maybe get rid of your Docker Compose file. Give that a try and don't just purely use test containers for your tests. That was one of the things I wanted to rush through now at the end. The other thing is that someone wrote me an email yesterday asking me what happens if I have multiple containers. And these contain my application. Actually, my application itself is inside a Docker container, and I'm booting this up as part of an integration test, and I boot my database up as part of an integration test. And how does my application container now know about my database and all that kind of stuff? And for that, again, you can still email me, but what I wanted to show you is a tiny link that's somewhat specific now to this user. There's a link. You want to have a look at test containers, advanced networking, because what you essentially can do, and that might make sense for everyone else, networking communication, there's a whole page on it, and you want to scroll down to advanced networking here. What you essentially can do is you can boot up like your MySQL database container and your local application container and join them all together to a big network. And then they can access each other basically without going through the host machine. So that is essentially what you would be looking at, just like an answer that I wanted to give to a question I got.
I'm glad you mentioned that because also Dalia, who's also on our team, is looking at doing video in this topic too, because it's really, really helpful.
Networking is a huge networking with Docker and stuff. It's again a huge topic, but just have it in the back of your head that somehow if you want to join multiple containers together in a network, they can talk to each other essentially. Yeah, right.
Right, we are like super out of time.
Sorry, yeah.
No, I didn't stop you earlier because this is really good. It was really helpful.
Cool. So then, yeah, from my side, I guess what I wanted to take away is just from this talk. You have test containers, get Docker up and running with WSL2. Remember that you can basically, you have these modules with these methods that you can orchestrate your MySQL container, RabbitMQ container, all these containers. You can always fall back to a generic container if there's no specific module. Think about the tests. Look out for Tricia's blog post, which will be coming up with the JUnit 5 support and getting rid of the abstract test class and the network stuff. And then I'm already happy.
Great. Thanks, Marco. I wanted to ask you questions from the channel, but actually I think a lot of the questions on the channel have been answered. I mean, you can always get Marco on Twitter, for example, can't you?
Yes, Twitter is fine. Twitter, Marco Behler on Twitter. Shoot me an email to marco@jetbrains.com. That also works. Yeah. Yeah,
this is great. So, I think I don't have any more questions at this point in time, and we are at the top of the hour. So I think it's time for Mala to come back and join us.
Yeah.
Thank you so much, Trisha and Marco. I really enjoyed the conversation, and it was amazing. And I loved the questions, Trisha, that you were asking, and a whole bunch of questions which were on the YouTube chat. And I'm so glad that Sergey and Kevin both were on the YouTube chat, and they were answering a bunch of questions. Thank you so much. And of course, thanks to everyone who's watching and who were asking questions. And a lot of other folks were also answering questions. So that was amazing. So I would say that was a great session.
Thanks for hosting, Mala.
It was a pleasure. Thanks for hosting, Mala. Thank you, Trisha, for joining also. It was super.
If you have any closing remarks, because I would like to mention about the next session that we have on IntelliJ IDEA live stream, which is next month. So if you have any closing remarks, please go ahead.
I'm just going to say thank you and bye. No, go ahead.
So before everyone leaves, stay tuned for our next IntelliJ IDEA live stream, which is on September 15th. Java 17 would be released next month, and we are hosting a session on it. It will be a combination of hands-on demonstration of how IntelliJ IDEA helps you to discover and work with the Java 17 features. And you would also hear from experts on the features that we developers should care about. Of course, with some do's and don'ts about the features and a lot more. So until next time, bye.
Bye. Bye.